calculator and part no calculator.
Johnny laughed.
I'm fine. No, he didn't do it. I did. I think his guess was broken. I'm sorry. Okay, so the whole first part here is no calculator. Notice that we are doing no calculator till we get down to about problem 5, except for that one little one in there. So here we go. Practice test, chapter 3. It is the one that says practice test, chapter 3. It does not say practice test number 2. It just says practice test. And we are solving this equation. Okay? Now, as with all things mathematics, there's always more than one way to start. One option you have is to divide both sides by 2. That would probably simplify things, make it a little easier. So I divide both sides by 2, that's gone, and that becomes a 2. Everybody got it? Now, what are we going to do with that? Well, we're not going to log both sides because we've already got a log in there. We want to get rid of that logarithm. So 3 to the second equals x minus 2. Remember, when you solve a logarithmic equation that has one logarithm in it, you want to get rid of the logarithm. So 3 to the second equals x minus 2. So 9 equals x minus 2, and x equals 11. Does anybody have a question about that problem?
Which problem is it?
That's problem 1A on practice test, the first practice test. Problem 1A. All right, 1B. In your review packet. I gave you 2 packets. One is a review packet, and it literally says at the top, practice test chapter 3. Now, I'm not talking about that anymore. You can keep messing around looking for it, or you can just pay attention and write down the problems. Solve this one. Is this one just like this one fundamentally? Yeah. So I'm going to solve it the same way. I'm going to say 7 to what power is the 4th root of 49? Now there's a radical in there. And we don't like radicals in logarithm land. So instead of a 4th root, we'll write that as what? 1/4 power. Now this is a no calculator problem, so I have to rig it. It has to be rigged. 49 is not a random generic number. 49 is 7 squared. So 7 to the x equals 7 squared to 1/4. Well, what's 7 squared to 1/4? What happens with those exponents? They get multiplied. It becomes 2/4, which is 1/2. So the answer to the question is 1/2. C, if you paid attention, you know what the answer is to C. The answer to C is 5. That's one of your properties. The 8's cancel. The answer is 5. We're not showing any work. We're just writing 5. Now, the next one, the next one is different than this one, right? Look, it has logarithms on both sides. And not only does it have logarithms on both sides, but it has 2 on both sides.
You need to shut up, man. I'm not doing it. That's Jim.
All right, so any ideas how we might proceed? Remember, I never want more than one logarithm on either side. So I got 2 logarithms. What am I going to do? Exactly. It'd be ln 38. Because when logarithms are added, the numbers are multiplied. That is one of your big properties. Now, same thing over here, except that's a subtraction. So this isn't going to be x times 2. It's going to be x divided by 2. Now it's easy. If ln green equals ln purple, then what? Green equals purple. So the answer to the problem is 76. E is another one that requires absolutely no work. What happens when you ln and e? They cancel. So the answer is 0.7. That's a property, no work, you just memorize it. Now what about F? What is going on with F? What's going on in F? What's the issue? Too many logarithms. Got 2 logarithms here. They have got to be put together. And since that's a minus, they're going to be put together as a division. So it's going to be the log base 8 of x minus 3 over 2 equals 1. What? It would be 8 to the first equals x minus 3 over 2. Guys, you have got to see the fundamental difference between this equation and this one. Do you see the difference? This one only has logarithms on one side. The only time you can drop the logarithms is when you have one on each side. Here, you can't drop it. All you can do is rewrite it. 8 to the first equals x minus 3 over 2. So 16 equals x minus 3, and it looks like the answer to the question is 19.
That's all she did with it.
All right, what about G? How many logarithms you got? 1. Just like this. What do you do when you only have one logarithm? You rewrite it. What's it say? X to the 1/3 equals 2. What do I need to do? X equals what? Because you cube both sides. And when you cube both sides, you get x equals 2 cubed or x equals 8. Remember, x to the 1/3 equals 2 is the same as the cube root of x equals 2. So you cube both sides to get rid of that cube root. So x equals 8. H, very scary, very easy. Do not like radicals in logarithm land. So I'm going to rewrite that 4th root how? So it's going to be the 7/4, the 1/4 power. And what happens when you ln e? They cancel. So the answer is 7/4. Part 1 done. Okay, so part 2. Now these are the time where we're writing our own equations. So you have to remember the kind of the format that you're shooting for. When I say exponential function, that's y equals what? ab to the x. A times b to the x. So for problem 2a, we are doing ab to the 2x. Anybody remember how we start this? we start by understanding that we're going to plug in the 0.04 first, the point with the 0. So when I plug that in, and this always happens, you're going to put that 0 in for the x, that's going to go away, so A is 4. Every time that's going to happen. It's called your initial value. So now your equation is y equals 4b to the x. What do you do now? Plug in the other point. So 16/9 equals 4b squared. All right, now how do I go about solving that? Divide by 4. Now, since there's a fraction involved, I might choose to multiply by 1/4 if that's easier for me. It makes no difference. It's the same thing. So either way, I'm going to come up with 4/9. Is that right? B squared equals 4/9. And then what? Square root both sides, so B equals 2/3. Don't put that in the answer blank. Remember, your job was to write the equation. So it's y equals 4 times 2/3 to the x. And we never, ever, ever multiply the 4 and the 2/3. All right, any questions about that? Remember doing those? Now, B is a logistic problem. All right, now you got to remember, these are a little bit harder. And you got to remember your general format is A over 1 plus BC to the x. That's your logistic. So when it says write the equation of the logistic function, that's it. Now, who remembers where we start with this one? It starts real simple. The limit to growth is right here. So we just start out by saying, okay, A is 18, that's the limit to growth. That's what we start with. And then I'll work on the rest of this. Now remember in problem A, the point 0.04, 4 was the initial value. So when I look at problem B and it says there's initial value of 6, that means you have the point 0,6. The initial value point is always the y-intercept. It's 0, whatever. So we're going to take that x and that y and plug it in. So 6 equals 18 over 1 plus b c to the 0. What's c to the 0? 1. So we have 6 equal to 18 over 1 plus b. So cross multiply, 6 plus 6b, don't forget to distribute when you cross multiply. So I got b equals 2. So keep in mind now, what that means is y equals 18 over 1 plus 2c to the x. That's what we've got so far. So now what? Plug in the other point, which is 2, 144 over 17. So 144 over 17 equals 18 over 1 plus 2c to the second. Everybody okay? So now what do? Cross multiply again. So I'm going to have 17 times 18, 306. equals 144 plus 288c squared. So 162 equals 288c squared. 9/16 equals c squared, so c equals 3/4. And again, you've done all that work. Don't get excited and forget to write down the equation. Y equals 18 over 1 plus 2 times 3/4 to the x. Final answer. Got it? Lots of steps to that one. 3 pieces of information given. Limit to growth goes on top. Initial value comes next. It's the 0.1 comma, or no, 0 comma, whatever, 0 comma, whatever. And then you plug in whatever that last point is. Right, number 3, state the domain, range, and asymptotes. Well, now wait a minute. In order to do this one, you're probably going to want to go back to your BFF. And remember that your exponential has an asymptote here. It looks like this, right? That's your exponential function. That's any exponential function. Okay, that's the base of any the baseline, the easiest picture. So in B, which is the exponential one, it says 3 to the x. This would be a picture of 3 to the x. It's a picture of anything to the x bigger than 1, anything bigger than 1 to the x. Now what's going to happen to that when you subtract 4 from it? What's going to happen to your exponential picture when you subtract 4? It's going to go down 4. So instead of the asymptote being at 0, which is where it is, the asymptote is going to be y equals -4. So it says list domain, range, and asymptote. Your asymptote for B is at y equals -4. Now, what's the domain of an exponential? All reals. Doesn't it go all the way left and all the way right?
Yeah.
It's all reals. What's the range? Well, the range of this one, of the base picture, the BFF, the range of that one would be y greater than 0. But remember, what did you do to this? You dropped it down 4. So what's its range? Y greater than -4. Or, if you wanted to be official about it, what? -4 to infinity? Now, your BFF logarithm has an asymptote here, and looks like that. That's what your regular, generic, baseline logarithm looks like. Now, what are we doing to this one? We're taking that picture, and what are we doing to it? What change does that make?
Is it supposed to be ln?
Takes it, it doesn't matter. Logs, LNs, it's all the same. They're all logarithms. That's your logarithmic picture. So whatever base you want to put on it is fine. The important part is right here. What's happening? 2 units to the right. So the asymptote that was at 0, x equals 0, is now going to be marched over, and it's going to be at x equals 2. Got it? Got an asymptote at x equals 2. So what's your domain? X is greater than 2, or 2 to infinity, if you want to write it like a real mathematician. What's the range of the logarithmic function? Up and down. How far does it go up and down? All real numbers. Forever and ever and ever. So your range of your logarithm is all real numbers. Oh, this is tricky. We talked about this. Not at great depth. All right, now, sketch it. What's another way to write it? Is it growth or decay? All right, let's sketch it first, because I think in sketching it, you're going to discover something. If I just said sketch that, now it says by plotting points, so why don't we do that? Why don't we go ahead and plot some points, since that's what it says. By plotting points, what I mean is set up a T-chart. Let's just plot 5 points. We'll just plot those simple ones. All right, so what happens if I put in, now be careful, I'm putting in -2. So that would be 3 squared, that'd be 9. All right, what if I put in -1? 3. What if I put in 0? What's anything to the 0? 1. Now, if I put in 1, I get 3 to the -1st, which is 1/3. And 2 would be 3 to the -2nd, which is 1/9. All right, let's go ahead and plot this. There's 0, 1. Here's 1, 1/3. Here's 2, 2/9. -1, 3, -2, 9. Gosh, when I connect these dots, I get this. That's backwards, isn't it? Can you explain to me why it makes sense that it would be backwards?
There's a negative on the x.
Exactly. And when you put a negative on your x, it reflects you across the y-axis. So if you take this picture right here and reflect it across the y-axis, isn't that what you get? And that's exactly what happened here. We took our basic exponential and reflected it across the y-axis. Does this equation express growth or decay? Decay. Now why? Remember, when we talked about this, we talked about a situation where you had like 100 times 1.38 to the x. And then we had 100 times 0.72 to the x. Remember that conversation we had? And this one represented growth of 38% because it's 1 plus 38. This one represented decay because it's 1 minus 28%, so it was a 28% decay. Well, you're looking at a 3 here, and you're thinking, well, wait a minute, 3 is bigger than 1, that should be a growth. No, that's not really a 3. Isn't this 1/3 to the x? It's really a base of 1/3, which is a number less than 1, and anytime your base is less than 1, you're going to have a decay. So you have to be tricky. So it says, what's another way of writing it? That would be another way of writing it. Y equals 1/3 to the x. There's a picture of it, and we got the picture by plotting points, physically plotting points. And obviously it's decay. All right, everybody okay with that? I think what we'll do now is stop, because everything else is calculator. So we'll do the calculator part when you come back from lunch. So wait, don't go anywhere. Let me tell you what time you need to be back.